Alright, let's dive into something mind-blowing. Imagine staring at the sun, not just a blurry orange disk, but a detailed, up-close view of its surface. Sounds impossible, right? Well, not anymore. Astronomers just dropped the highest resolution image ever taken of the sun's surface, and it's a game changer. But here's the kicker, it's not just about the image itself. What they've discovered could rewrite our understanding of how the sun works. Let me explain. First, the basics. This image comes from the Daniel K. Inouye Solar Telescope in Hawaii, and it's not your average snapshot. It reveals tiny, whirlpool-like patterns in the sun's plasma that no one's ever seen before. These aren't just cool visuals, they're clues to some of the sun's biggest mysteries. Personally, I think this is where things get really interesting. These patterns aren't random, they are linked to something called Kelvin-Helmholtz instabilities. If you're not a physics nerd, that's basically what happens when two fluids slide past each other at different speeds, creating ripples or vortices. Think of it like wind blowing over water, but on a cosmic scale. Here's where it gets wild. These vortices are happening at the edges of these massive structures called granules, which cover the sun's surface. Each granule is huge, up to 2,000 kilometers wide, but the vortices themselves? Some are just 20 kilometers across. To put that in perspective, it's like spotting a coin from 180 kilometers away. What many people don't realize is that these tiny processes could be driving some of the sun's most extreme behavior. For example, researchers think these instabilities might explain why the sun's outer atmosphere is millions of degrees hotter than its surface. That's insane, right? If you take a step back and think about it, we are talking about processes happening on a microscopic scale, relative to the sun, that could be powering its entire atmosphere. But there's more. These vortices might also play a role in how magnetic energy moves around the sun. In my opinion, this is a huge deal. The sun's magnetic field is what drives solar flares, coronal mass ejections, and all the space weather that affects Earth. If these tiny plasma whirlpools are influencing that, it's a big piece of the puzzle we've been missing. What this really suggests is that the sun's surface isn't just a chaotic mess, it's a finely tuned system where even the smallest details matter. One thing that immediately stands out is how this discovery challenges our assumptions. For years, we've known the sun's surface is dynamic, but we've never seen it like this. It's like finally getting a high-def TV after watching everything in standard definition. From my perspective, this is just the beginning. With telescopes like the Inouye, we are going to keep uncovering these hidden processes, and each one could flip our understanding of the sun on its head. What makes this really interesting is that it's not just about the sun, it's about stars in general. If these instabilities are happening here, they're probably happening elsewhere in the universe. This raises a deeper question: how much of what we think we know about stars is based on incomplete data? A detail I find fascinating is how this image was even possible. The sun's light is so intense that capturing this level of detail requires insane precision. It's like trying to take a photo of a lighthouse beam with a smartphone, except the lighthouse is a million times brighter. The fact that we've managed to do this is a testament to human ingenuity. But it also highlights how much we still have to learn. Personally, I think this is just the tip of the iceberg. As we keep pushing the limits of our technology, who knows what else we'll find? So, here's my closing thought: this image isn't just a pretty picture. It's a reminder of how much we still don't know about the universe, and how much we are capable of discovering. If tiny plasma vortices on the sun can hold the key to its biggest mysteries, what else are we missing? Let me know what you think in the comments. Are we on the brink of a solar revolution, or is this just another piece of the puzzle? Either way, it's an exciting time to be alive.